The new section is entitled Triangle Application Theorems. And the number one fact about a triangle is, no matter what the triangle is, the angles must add up to 180 degrees. Here is a very arbitrary looking triangle. Label it A, B, and C. And through point C, I draw a line parallel to AB. Okay. And I call this angle 1, and I call that angle 2, and I call that angle 3. And since this is a straight angle, I know the sum of those angles, angle 1 plus angle 2 plus angle 3, is 180 degrees. But angle 2 is angle C. But you know what? Here's my V. Sorry, my Z. Those two lines are parallel. This line and the one on top. So there's my Z. That means this angle and this angle are equal. That is, angle 1 is really angle A. And I have another Z going right here. Here's another Z. This angle 3 and angle B are the same. Angle 3 is really angle B. And you still add up to 180 degrees. But then you say, wait a minute. A, C, and B, those were the three angles of the triangle. They add up to 180 degrees. Okay, now, this point, you don't have to accept that. That is, your teacher said it's true, and you just believed your teacher. Well, now, you don't have to believe your teacher anymore. We proved it. You don't just have to believe him or her. It really is true. We proved it. Okay. Next thing we'll talk about is exterior angles. Exterior angles. Remember, exterior means outside. When it comes to a triangle, an exterior angle would be outside the triangle. You have triangle A, B, C. And let me move C. So A, B, and I'm going to extend the line at C. This angle number 1 is exterior. And I claim that angle 1 is equal to angle A plus angle B. And they have a name for those other interior angles. These are remote interior. With respect to angle 1. Okay. Now, why is this clearly true? Well, I know that angle C plus angle 1 is 180 degrees. So solving for angle 1 by taking away angle C from both sides, I have that angle 1 is 180 minus angle C. Okay? But I also know that angle A plus angle B plus angle C, they're angles of the triangle, just add up to 180. If I take away angle C from both sides, so let me actually do that. If I take away angle C from both sides, I get that angle A plus angle B also equals 180 minus angle C. If two quantities equal the same thing, if two quantities equal a third quantity, we can conclude, therefore, angle A plus angle B is equal to angle 1. In other words, whatever this angle is, those two angles, the sum of those two angles is what you add to this to get to 180. Whatever these two angles add up to, that's the magic number that you add to angle C, the question mark angle, to get 180. But that's exactly what angle 1 is. It's what you add to this to get to 180. That's why they're equal. Angle 1 equals angle A plus angle B. Now, just to be very clear, if we, A, B, C, let's label it the same way, if we extended the line that way, then this angle 1 would have angle B and angle C as the remote interior. Remote interior angles are with respect to the exterior angles. Angle 1 is exterior. Now, I do want to point out that there's more than one exterior angle at point A. Well, this triangle is in front of me, so let's use it. The one to the left, this triangle. We're going to talk about angle C. A, B, C. Well, I could have extended the line that way at C. Could have extended BC. Well then, this is also exterior. But it's the same as the other angle 1 to the left. And the reason is, if I extended this, we have that. They're opposite angles. They're equal. So it doesn't matter which way you extend it, whether you come down this way or this way. Those exterior angles are going to be equal to one another. Okay. So an exterior angle to, so you have a triangle, and you have an exterior angle at one of the angles of the triangle. You have a triangle, A, B, C, and you have an exterior angle. This angle adds up to, the sum of these angles, A and C, add up to that exterior angle. That's some big theorem. You don't want to have to prove that every time. That should be a fact that you know. Okay. Let us prove something like this. This is the diagram. That's 40 degrees, A, B, and C. The instructions are to find A and B. Well, these two angles are equal because we have an isosceles triangle. These two angles is what you add, the sum of those angles is the magic number that you add to 40 to get 180. The answer is 140. Angle A plus angle B plus angle C is 180. But we know that angle C is 40 degrees. So, whatever this is, we know that when you add 40 degrees, you get 180, And that answer is 140. 140 plus 40 is 180. I mean, I know, here's 40. I want to add something to get 180. Well, 0 plus 0 gives me 0. 4 plus 4 gives me 8. There's an understood 0 here. Plus 1 gives me 1. It's 140. So angle A plus angle B is 140 degrees. But A and B are equal. That is, instead of B, for example, I can write A. They're equal. So 2 times angle A is 140. Well, 2 times 70 is 140. So angle A is 70. But angle B is the same. So they're able to find angle A and B just given an isosceles triangle. All I'm given was this, and 40 degrees. And are they able to figure out the other 2 angles are each 70? Now, if you didn't tell me that it was an isosceles triangle, and nothing else, all I can say is that those 2 angles add up to 140. Okay. So we have a triangle like such. This is extended. This line is extended in both directions. And so is the straight line. Okay. And we'll number the angles 1, 2, 3, 4, 5, 6, and 7. Write the 4 a little bigger. And we are given that angle 1 is 130 degrees and angle 7 is 70 degrees. The instruction is to figure out everything else. Right. So, angle 7 is no longer angle 7. It is 70 degrees. Opposite it is also 70 degrees. And angle 1 is 130 degrees. Well, that means 2 things. This angle is 50 degrees because that's what you add to 130 to get 180. Because this is a straight angle. Now, you can find angles 3 in one of 2 ways. You can say 70 plus 50 is 120, and what do you add to 120 to get 180? Well, 0 plus 0 is 0, 2 plus 6 is 8, and 1 plus 0 is 1. So it's 60. Angle 3 is 60 degrees. Or you could have said that with respect to the 130 degree angle, these are remote interior. They should add up to that angle. They should add up to the exterior. 70 plus what is equal to 130. Well, 0 plus 0 is 0. 7 plus nothing gives you 3, but 7 plus 6 gives you 13. 3, bring down the 1. So it's 60. Alright, 3 and 4 are supplementary. That is, they add up to 180. Well, 6 plus 12 is 18. 60 plus 120 is 180. Angle 6, being exterior to the 70 degree angle, must add up to 60 plus 50, which is 110. Or, you could have said that's a straight angle, and what do you add to 70 to get 180? 110. Okay, so we found out everything. Of course, this is also 110, and this is 120, because opposite angles are equal. Opposite 60 is also 60. We wanted to extend this. Opposite 50 is 50. Opposite 130 is 130. So I found everything. And all I was given were two angles. Two angles determine that whole triangle. Interior, exterior, all of that stuff. Suppose we have an isosceles triangle like such. Isosceles. A, B, and C. And we are given that angle A is 30 degrees. And of course, AB is congruent to AC. It's already in the picture. And that CD, that's D, excuse me. CD bisects angle BCA. And BD is one of the trisectors of ABC. And they want us to find angle B. Now, I want to draw this a little bit better. Maybe I'll move D. D. All right, so 30 degrees. But the other two angles are equal. The other two angles are equal. Okay, so just want to write this up nicely. CD bisects the angle. So those two angles are equal. Now, basically, probably more interesting to find angle D. Okay, the first thing is I want to find angle B and C. I want to find angle B and C. We know that angle B equals angle C because the big triangle has two sides equal, which means the opposite angles are equal. Okay. Now, angle A is 30 degrees. So how much is left over for angle B and angle C? Well, the other 150 degrees. Those two numbers add up to 180. But B and C are the same. So they're each going to use half of the 150. They're each going to use 75 degrees. Okay, now this is where it all comes together. Big angle C is 75 degrees. So that means this little angle, since it was trisected, is going to be bisected. Is going to be 37.5 5 degrees. Okay, 37.5 degrees. Now, this part of angle B, it looks to me like this one is the bigger one. That's the twice. That's 2 times. This is 2x, and that's x. And we know that 2x plus x is 75 degrees. That is 3x is 75 degrees. 3 times 25 is 75. 3/4 are 75. So x is 25 degrees. And if I call this angle y, y is 37.5. Well, if you were to add angle x and angle y carefully, you would get 62.5. But those are 2 angles in that inner triangle. This is angle x, this is angle y, and there's D. Well, what do you add? So D is going to be whatever it takes to add to 62.5 to get 180.0. Line up the decimals. 5 plus 5 is 0, carry the 1. 1 plus 2 is 3. To get 0, have to add 7. That's 10. Bring down the 0, carry the 1. That's 7. You want 8. So add a 1. Now you have the 8. And then you want 1. There's nothing here, so you add 1. The answer is, that's angle D. Angle D is 117.5 degrees. Let's try a couple more. Suppose you have this. And that. E, F, G, H, and point J. We'll even call that K. So that's what's given. Alright, now we're given some pieces of information, like angle E is exactly 70 degrees, JH and FH, they bisect the exterior angles of JEF, the exterior angles of triangle JEF. At J and F. Okay, so we have that. Now, we want to find the measure of angle H. How much is angle H? Well, although we probably can't read it very nicely, we know angle E. Angle E is 70 degrees. And JH and FH and FH bisect the exterior angles of triangle JEF. This triangle here. Okay. Now, when it comes to point J, if you ignore this line for one moment, if you ignore that line for one moment, that's the exterior angle of the triangle. Okay, and this line bisected that angle. That is, if I call this X, well then that's X. Now, in that same triangle, FH bisected the exterior angle at F. Well, let's just look at this inner triangle, EJF. This is their exterior angle at F. But FH cut it in half. That is Y and Y. Okay, and we want to find angle H. Okay, so we want to find angle H. Right. Now, this exterior angle is 2x. And maybe we'll call this Z. We know that 2x must equal to, in this triangle, not that angle, not angle W, but the other two. It's 70 degrees plus Z. Okay. We know that 2y's is not this angle, but the sum of the other two in this triangle. It is angle 70 plus W. Now, if we oh, that won't work. Okay. Angle H. Well, try to add these, because I really want to know what x plus y is. Because if I knew in this triangle, if I knew what x plus y was, then I know what angle H is. 2 times x plus y is 140 plus Z plus W. Dividing by 2, I'm going to divide it by 2 that way. I learned that x plus y is 70 degrees plus half of Z plus W. But now we're done. We're done at this point, because I know what Z plus W is. I know what Z plus W is. Look at this triangle here. One angle is 70 degrees in that triangle. In triangle EFJ, I know that 70 plus W plus Z is 180. Well, 70 plus 110 is 180. That is, W plus Z is 110. So divided by 2, whether you write W plus Z or Z plus W like I wrote over here, it is 55 degrees. So angle X plus angle Y is 70 degrees plus 55 degrees, which is 125 degrees. But looking at this triangle where I just put the X, it has angle X and Y, which add up to 125. And H is what remains. If you add H to both sides, when you add up those three, you're supposed to get 180 degrees. They're the three triangles. Sorry, they're the three angles of a triangle. And on the right side, you have 125 degrees plus h. Well, 125 plus 55 is h. Okay, so we found the measure of angle h. Angle h equals 55 degrees. Let's try one more. Have this triangle right here. Okay. A, B, C, D, and E. And they tell us a couple of things. They tell us that AB is congruent to AC. And they tell us that AE is congruent to ED, which is congruent to BD. Which is actually congruent to BC. So whether the picture looks like it or not, AE, ED, BD, and BC, they're all equal. And AB and AC, they're equal. Which tells us that this angle and this angle are equal to one another. Okay, well, we'll talk about that in a moment. You have to remember to use this information. Angle 1, and that's also angle 1. Base angles of an isosceles triangle, triangle number 1, base angles are equal. Triangle number 2, we have two sides equal. So, the angles opposite them, which happens to be called base angles, they're equal. Okay, and in triangle number 3, we have two sides equal. The angles opposite them, call them angles 3, they're equal. Okay, and let us call this angle 4. Now, I know that angle, so since AC and AB are equal, and it's a triangle, then their base angles are equal. That is angle 1. We know angle 1 is equal to this big angle here. Angle 2 plus angle 4. And actually, I didn't state a question, but they want us to find angle A. They want us to find angles 3. How much is angles 3? Okay, and basically, I think it's just going to be a lot of our alphabet soup. Call that angle 5, and call this angle 6. Well, when it comes to triangle number 1, we know that 1 plus 1 plus 4 is 180 degrees. And when I write 1, I don't mean the number 1, I mean angle 1. And in triangle number 2, we know that 2 plus 2 plus 5 is 180 degrees. And in triangles 3, I know 3 plus 3 plus 6 is 180 degrees. And then I look at straight angles. Like at angle E, I know that 2 plus 6 is 180. And at angle D, I know that 1 plus 3 plus 5 is 180. And my job is to figure out what angle 3 is. So I'm going to write everything I just did a little bit higher. Angle 1, well, not that high. Angle 1 is equal to 2 plus 4. 1 plus 1 plus 4 is 180. 2 plus 2 plus 5 is 180. Let me get rid of this because I need the space, so I'm moving it up. 3, 3, 6 is, oh, I have to erase it. 3, 3, 6 is 180. 3 plus 3 plus 6 is 180. And 2 plus 6 is 180. And 1 plus 3 plus 5 is 180. And I guess one other one. The sum of their angles of this triangle, the big triangle, ABC, is also 180. Angle A is 3, angle B is 2 plus 4, and angle C is 1. This is also 180 degrees. Now somehow I need to use this information to find angle C, angle 3, which happens to be angle A. Alright, so let's see how we could do this. And you can use what's called linear algebra, but let's not do that. Okay. So, I'm going to use this last equation. 3 is 180 degrees minus 2, 4, and 1. I'll write 1, 2, and 4 in order. But now, we know that 2 plus 4 is simply 1. So this is 180 degrees minus 1 plus 1 is that one. 2 plus 4 is another one. Alright, so if I can only find out what 1 is. Do I know anything about 2 and 4? It equals 1. So, it's just alpha, it's just playing with these equations. Just make sure I have all of them. 114 is 180. 225 is 180. 336 is 180. 2 plus 6 is 180. 1, 3, and 5 are 180. And the sum of the three angles, 1, 2, 3, and 4, is 180. Okay, so I'll try to erase this. I didn't succeed very well. So we want to find out what angle A is, which I called angle number 3. So if you take away two angle 1s, now, for whatever this is worth, this here tells me, that equation tells me that 180 Maybe this will help. 180 minus the 1 plus 1 is 4. But we also know that it's 3. So angles 3 and angle 4 are the same. Now, this is where I get destroyed for erasing my diagram. One, 2, 3, and 4. I suspect I call this 1, 1, and that 4. And then 2, 2, and 5. And then 3, 3, and 6. So that wasn't so bad. So we just learned that 3 and 4 are the same. Okay, so instead of 4, I can write 3. So wherever I have a 4, I'm going to put a 3. Wherever I have 4, I'm going to put a 3. Instead of 4, I put a 3. Instead of 4, I put a 3. Now, what about exterior angles? What about exterior angles? Maybe that's key. Let's look at triangle number 3. Let's look at triangle number 3. If I extend it, I now know that 2 is equal to not 6, but 3 plus 3. Likewise, if you go into triangle number 2 and you extend it the same way, I know that angle 6 is not that 2, but the other 2 angles, 2 plus 5. Now, if you also extend angle 3, triangle number 3 that way, you know that 1 plus 5 is not 3, but 6 plus 3. And at some point this is just going to click. We know 3 and 4 are equal. 6 is nothing more than 2 plus 5. Okay. So we know that 3 is 4. So if we can find 3 or 4, we're done. Right. I don't seem to be seeing this, but you just have to hit on the right combination. For example, 1 plus 5 is 6 plus 3. This here is 6 plus 3, plus another 3. But that's exactly this one. That is, this one doesn't contribute anything. Now, this last one, we know that 3 plus 3 is 2. So 3 plus 3 is 2, plus the other 2, plus the 1. This is 180 degrees. 1 plus 1 plus 2 is 180 degrees. Oh. Did I write that down wrong? 2 plus 2 plus 1. Okay. So now, if you look at triangle number 2, you have 2 plus 2. Well, whatever you add, angle 5 should be that so 2 plus 2 plus 5 is 180. That means 1 and 5 are the same. 1 and 5 is the same. That is, this is really angle 1. That's really angle 1. Angle 5 is really 1. So I see a 1 and a 5 in that equation. I'm going to put 1. And I see a 5 in this equation, and I'm going to put 1. And I see a 5 in this equation, and I'm going to put 1. Okay, I'm going to look at this last one that I have. 1 plus 1 is 6 plus 3. And in triangle number 1, I see 1 plus 1. And in triangle 1 and 2, I have 1 plus 1. Now, 2 plus 1 is 6. I think that will help us. 2 plus 1 is 6. Okay, now remember, 2 in triangle 2, 2 plus 2 plus 1 is 180 degrees. But 2 plus 1 is 6. So 2 plus 6 is 180. So let us add that on. 2 plus 6 is 180, but I already have that one right here. So it's just showing that we didn't make a mistake. Okay, it's a lot of alphabet soup here. One, two, doubles 3 is 180. Yeah. Okay, let's see if we have any other exterior angles. Well, in triangle number 1, we extend this line. So 1 plus 3 should equal to not that angle, but the other two angles. And of course they do. Now, let us reverse that game. Let's go to triangle number 3. Extend it out here. So 1 plus 1 should not equal 3, but the sum of the other two angles, which is what I have here. Okay, so now I can say that angle 2 and angle 6 are the same. Angle 2 and angle 6 are the same. Okay, angle 2 and angle 6 are the same. Because angle 6 is exterior to triangle number 1. So angle 6 is not this angle, but the sum of the other two angles. Angle 6 is 2 plus 1. But I already have that. So I'm just looking at all the equations to see if I can come up with anything. Okay. We know that 6 equals 2 plus 1. It says it right here. If I add 2 to both sides, I get 2 plus 6, which I am told is 180. And this is 2 plus 2 plus 1. Okay, but I already have that. I'm just not seeing this one. But this is clearly the way that you do this. And I did say 1 equals 2 plus 3. No, that 1. So remember that this line and this line were equal. So angle 2 plus 3 should equal angle 1. 2 plus 3 is 1. Let's add that one. 2 plus 3 is 1. So we want to know what angle 3 is. Spend another moment on this, but I'm really not seeing this. 2 plus 3 is 1. Okay, so 2 plus 3 is 1. So you have 3 plus 1 is 180. But that one you have up here. So we don't need this equation anymore. All right. Let us look at those two equations. 3 plus 3 plus 6 is 180, and 2 plus 6 is 180. If we subtract, this cancels and that cancels, so the right side is 0. So 2 3's minus 2 is 0. That is, these must be equal. 2 is 3 plus 3. 3 plus 3 is angle 2. So if you look at triangle number 3, you have 3 plus 3 plus 6 is 180. But 3 plus 3 is angle 2, plus 6 is 180. 2 plus 6 is 180. But we already had that one. So the more I do this, the more, I'm never getting a contradiction. I don't think I made any mistakes anywhere. And I know there's a handful of you out there saying, well, why don't you just do this? It follows immediately. Well, good for you, but I don't see it. I do not see this one. I want to list everything that we have. 2 plus 3 is 1. Ooh. But 2 is 3 plus 3. And 6 is 2 plus 1. And 1 plus 1 is 6 plus 3. Okay. Spend a couple of more minutes because I see angles being trisected and angles, I think I saw an angle being bisected, but I definitely just saw a triangle being trisected. Let us look at these two equations right here. Okay, And let's see what we can glean from these two equations. 2 is really 3 plus 3. So in the top one, 2 is 3 plus 3, plus another 3, we get 1. Okay, well, what that tells me is that we trisected the angle. It's 3 plus 3 plus 3 is angle 1. Okay, that does it. That does it. That does it. Look at triangle number 1. Angle 1 plus angle 1 plus angle 3 is 180 degrees. But angle 1 is 3 plus 3 plus 3. Plus another angle 1. 3 plus 3 plus 3. Plus another angle 3, which is 3. This is 180. 7 times angle 3 is 180 degrees. Divide by 3, divide by 7, angles 3 is 180 degrees divided by 7. Okay, unless I made a silly mistake somewhere, angles 3, which is angle A, is 180 degrees over 7. Okay, let's make sure that makes sense. 7. Triangle 1, the angles add up to 7 times angles 3. Okay, so that finishes that problem, and it finishes the section, and it finished me.